Hello, all. Welcome back to the channel. In this lecture series, we'll be discussing about several sensors that we use in our day-to-day automobiles. To start off, we'll discuss about knock sensor. To discuss about knock sensor, we must know what is knocking. Knocking, it is high-frequency vibrations that give rise to ping-like sound inside the engine. So, what are the causes for these? So, the ping-like sound that is knocking, these are caused by few factors. That is, it can be caused due to low quality fuel, or it can be because of some deposits on the cylinder wall, or it can be because of the improper selection of the spark plug. So, how can it be prevented? So, to prevent that, there are different. You have to like go through maintenance and have some knocking sensor and so on. So, we'll discuss about it in brief. To start off, NOx can remove the power from the engine, and in worst case, it can also destroy it. To prevent knocking, the the engine needs to run in low compression ratio and higher octane fuel. So this changes the engine's working property, and also thus also the impact of the driving habits will also affect the knocking principle. Knocking in the engine. So we'll see how knocking can be identified much earlier, and then maybe like necessary steps can be taken to avoid that. First off, the knocking sensor works on a principle called piezoelectric element. So we already know what is a piezoelectric effect. So piezoelectric effect is nothing but when the piezoelectric crystal or ceramic it is subjected to some electrical impulse, it experiences some vibration. Or vice versa, there will be when it is when it is subjected to some vibration, it gives out some electrical output. So ceramics and single crystal materials of piezoelectric type. Some examples are like quartz, tourmaline, and gallium phosphate, so on. So these are some of the materials that can be used for knock sensor. So these knock sensors will be incorporated near close to the engine, and these will try to identify if knocking is happening in the engine or not. So how does this sensor work? So knock sensor, it generates a voltage when there is vibration applied to that using the piezoelectric effect. So as said earlier, whenever it is subjected to some mechanical stress, it is converted into electrical output, electrical behavior. So this behavior of the piezoelectric material will give us the say change in the voltage. So due to vibration, a counterweight inside the sensor is applying pressure, and the piezoelectric element will exert some electric charge. So this charge will be converted, and we'll get an output signal which will identify if there is knocking happening in the engine or not. So the circuit, so as you can see here we have the knock sensor. So the knock sensor sends the electrical impulse, right? So ECU of the engine, that is the engine control unit. So what it does is it analyzes the electrical signal that is coming out from the knock sensor, and it sends to the igniter. So it acts as a feedback mechanism to identify if there is knocking, to change whatever parameters that is necessary to be changed to avoid the knocking further. So once the signs of detonation or this knocking is detected, the knock sensor sends the voltage, as said earlier, to the ECU, which retards the spark timing slightly to avoid detonation. So what are the benefits of this knocking sensor? So vehicle engines work more efficient and produce more power when operating near the detonation limit. Um, Although it is said simply, knocking sensors allow optimum engine performance and protect the engine from potential damage caused by detonation. The applications are the piezoelectric effect is found in many applications like in automotive industry. Knock control for internal IC engines, it is one of the application areas, and we have like machine tool protection, cavitation detection, monitoring of pivot bearings, and anti-theft systems. So what are the challenges here are that the piezoelectric elements can be very sensitive to more than one physical dimension. So the vibrations that it is experiencing, it might not, sometimes might not be because of knocking, can be like different reason as well. Another challenge is that while operating in harsh environments, like when it is full of dirt, grease, or moisture, when if it is close to sea, maybe like salt deposition, these can also affect the its performance for that, but maybe like automotive or any other sort of application. The ceramic materials lack long-term stability, so it cannot be used for long-time ranges. And the sensor can be fooled by things like bad water pump or alternative bearing or loose rod bearing. So probably maybe a small homework would be like try to find out what are the different varieties of knock sensors that are available in the market, and try to find out if there are any alternative working principles. Thank you.